Howdy class. This is our short Thanksgiving week video. We're going to just cover the random and math packages in this video. I really want to encourage you first read through chapter 11, especially sections 11.1 to 11.7, because it does go into a solid introduction for the random package. And this notebook here will demo most of those, that code there you see there, but we go further. So to provide it all context, it's going to be best that you do the reading first before you take a look at this demo in lab. All right, so here it is popped up. The random package is a very powerful set of functions and methods, and we get them by importing, of course, random. Now, we've used this before. This is no new code for you. The random.randint method will provide a random integer within the bounds of low and high there delineated by A and B. So we've used this before in quite a lot of our code. Now here up next is just a very quick way to use list comprehension to create your set of random integers. And let's break this down over on the whiteboard. All right, hopefully you're seeing the whiteboard now. So this statement here will create a list using list comprehension of random integers in a certain range, A to B. Here is the list comprehension syntax for it. And this simply breaks down to the code below it in blue if we wanted to manually code this. So this segment here for blank in range R, that forms the for loop header. LST is the name of our list. And if we were to manually do it, we would just create the empty list. And this random number generator here is what it gets appended every time through that loop to create the list of integers. And just, remember, list comprehension is just a terrific skill to nail because it does compact and compress your code quite a bit. Okay, let's go back to the canvas. All right, so after that list comprehension is done here, well, then you will have, as part of your lab, a little challenge here to create. You'll have to generate these 25 integers in the range of 0 to 1,000 in a one-dimensional Python list. And this is separate from the NumPy arrays that we looked at last week. We're just dealing with typical Python lists now. And once you get that list created, then go ahead and output it using solid output formatting in a really nice 5x5 grid. Now, next, here's some code that will create random floating point numbers. And there's a couple ways to do it. First, if you just need a floating point number between 0 and 1 with a lot of precision, you can just use random.random, and that returns that floating point number there that you see on the screen. Now, you can encapsulate that within round and then give it the number of decimal places that you want to see there if you want to kind of truncate some of those results and just round it so it's a little more manageable, especially when we're printing out output maybe within fixed field widths, or we had some other formatting requirements that we needed to line up. All right, that brings us to the second challenge for you. Using dictionary comprehension this time, go ahead and create a dictionary. The keys are the integers 1 to 10. And the values are all random floats, just with 4 places of precision. And we can use that same random.random method for this, since we're not going to bound the random numbers. So we're just going to call them between 0 and 1. And then this time, go ahead and make the output real nice like this. Separate the keys and the values using .items, and then you can output this quite easily in a list, or in a loop, I mean. Now, that's all good, but if we wanted to create random numbers in a certain range that were floating point numbers, well, then we've got to use random.uniform. And random.uniform will generate floating point numbers, again, between a low bound and a high bound. So here's another example of using list comprehension to develop a random list of floats between the range 10 and 20. So let me break this down for us also on the whiteboard. All right. Once again, we're using list comprehension, this time to develop that list of 10 random floating point numbers between the ranges of 10 and 20. So I mentioned before that we'll use random.uniform for this. And here's that function call right here in the center with the lower and upper bounds. Then for convenience, again, since this is going to generate random numbers with a lot of precision, you can bound that with the rand function. So here round function. So I'm going to put a wrapper around the random number that gets returned and just format that and round it to 3 decimal places. And then here we have the same loop that we'll use to generate 10 of these random numbers into this particular list. All right, back on the notebook now, you'll see that here you've got a little bit of code to do there to modify your previous dictionary and change it from an integer to a float and having some different bounds there. Now, random gives us a couple of different ways to select elements from a list randomly. The first is just .choice, and .choice will give us one random element from the list. So you can see here in this code here, I provide it with a list, and then I'm just going to simply print out random.choice and then give it the argument, whatever container we're looking to get a random element from, and here it output a 5 for us. Here's another example where I give it a string containing all of the vowels and ask it to just give me a random vowel, and there it does. It gives me an E. Now, the next two things to take a look at is the way to obtain multiple random elements from a list. But there's 2 ways to do this. One is without replacement and one is with replacement. So let me draw this out, and that'll help kind of explain what the with replacement and without replacement is. All right, here I've got a 6-element list with some integers in it, 10, 20, 30, 25, 15, and 5. Now, if we were to randomly pick one of these, we could use that easily, or do that easily now. If we wanted to pick 2 of these, well, the question is, after we pick the first one, does that element or that item get replaced so it's eligible to be picked again? Or is it not replaced? So here's an example. Here's random selection and replacement. 2 sides that we'll examine with and without replacement. So without means that if we pick, let's say we pick a 10 here, well, then the resulting list is going to be 20, 30, 25, 15, and 5. So if we were to run the code to pick another element, if we were to say, run choice again, then we could, let's say, pick 15. So then we'd get 15, and then the eligible choices are these, 20, 30, 25, and 5. Now, clearly, selecting without replacement gives you just a limited number of opportunities, because once that list has been exhausted, well, then there's nothing else to pick from. So you're limited to the number of operations in picking elements in that list with .choice by the number of elements in the list. So the difference with replacement is that once that number's picked, it's replaced with a carbon copy, and we can pick any number again, including that one. So let's say we picked a 10. Well, the resulting list is going to be the exact same list because we took this one out to pick it, but then we replaced it with another copy. So then we pick a 20, and the 20 goes out, but it's replaced with 1. So our resulting list is still the same. Now there's two different Python methods that we can use for this to make sure to capture the with replacement and the without replacement behavior. And these are going to be, we will use .sample for without replacement, and then we'll use .choices for picking with replacement. So now let's take a look at some sample code in the notebook. All right, here is selecting without replacement. And as I just wrote on the board, we'll use .sample for this. So here, .sample will take a couple of arguments. One is clearly the list or container that we're going to select from. And then the other is, well, okay, given this list that we're going to select from without replacement, how many elements do we want in our new list? Or in other words, we're going to select a subset. How large is the subset? So the code for that is right here. We'll just simply call random.sample, give it the two arguments. So there's the list called cars, and it's saying, okay, out of this list of 7 cars, give me 5 at random. And because it's without replacement, that means that there's no possibility of these being repeated. And you can see there the output string, and it picks 5, and there are definitely no repeats in that. And if we were to run this and run this and run this, we would get the exact same thing. And let me do that real quick. Okay, this time was Expedition, Taurus, Escort. No repeats. This time Focus, Expedition, no repeats. So you get the idea there. Now, if we want to allow repeats, well, that's when we're going to use the .choices method, .choices. And this time it's going to take 3 arguments, okay? One is the list that it's going to select from. The second is an optional additional list of weights. And I'll draw that out in a second. And then third, again, is the number of elements to get from that list. Now, since there's the possibility that repeated elements will be randomly selected, well, here's a situation where we could never run out of eligible elements to be randomly selected because we can just keep repeating them over and over and over. So we could get a list of any size generated using this method, and we're not going to hit that error of running out of elements. Now here's some sample code. Here is just a bunch of West Coast airports, and they're listed by their 3-letter airport code. And here, all I'm going to do is call random.choices and say, okay, out of this list of 8 airports, give me 5. These will be with replacement. So we might easily have some repeated values. Now the K argument is going to equal the number of elements to get from that list. So when we run it here, we see that, yep, there's a few results there, maybe a couple of repeated values will be evident. Like in this first output line, we've got the Burbank airport that's repeated twice. So we see that, you know, this possibility of double selection is possible. Here in the third line of output, Sacramento, SAC, is listed twice. So we're seeing this, this in action. Now, what we can also do is assign weights to each of the values if we wanted to give it more of a weighted selection. And let me draw that out on the blackboard to show what that means. Okay, back on the whiteboard here, I've got a list of those airport codes, and I don't have them in quotes or anything. This is just kind of pseudocode. And then there's a parallel list that represents the weight of each of these elements. And a good way to look at it is just, you know, how much more probable is one over the other. And you can see here, you know, SFO is 10 times, it's got a 10 compared to Burbank here, which has got a 1. So we can say that it's 10 times more likely to select SFO rather than Burbank. And then accordingly, have your weights mapped out however you need. Now, these are just simply relational weights. You know, you could easily say, all right, I want SFO to be twice as likely, maybe LAX 1.5 times as likely, everything else will be 1, except maybe I want Burbank to be half as likely, and maybe I want San Diego to be a quarter as likely. And you could just plop those into the weighted list, and the selections then would be made according to those weighted values. So back in the notebook now, we see here, yep, those are those weighted values. And let's for kicks here, let's change those to the 2, 1.5, 1, 0.5, and 0.25. And then you see there that we got a brand new selection of airport codes based on that weighting now. All right, and then you've got a little, now you tripart, got some names here, and we want to select those randomly using the requirements here, and then you've got a couple of extra operations to do. Now, shuffling a list is quite easy with the math library. We're just simply going to call random.shuffle and give it the container name, and it will shuffle that. And it doesn't necessarily return anything, so you don't have to reassign it to any, return a list to any variable. It's just going to do an in-place shuffling there. So you can see here, we're going to create random integers between 10 and 25, and we'll create 10 of them. We can go ahead and use the blank for this if we choose to, since the index is unimportant. And there is our first presentation of the list. We call shuffle, and then there is our second presentation of the list, and you can see, yep, in fact, those values are shuffled. So you'll have a little exercise here for shuffling. And then the last thing to create is just a way to create random numbers, but to inject bias into it. Now imagine if we wanted to select numbers from 0 to 1,000, and if we were to, randomly pick numbers, we would hopefully see a uniform distribution over many, many selections. However, we can kind of bias that. Let's say that we want to bias it toward lower numbers. Well, we could insert a bias value into our random number generator, and it will conduct that bias for us. And we'll use random.triangular for this purpose. And it's going to simply take the 3 arguments, the low boundary, the high boundary, and then a bias number. And of course, the bias has got to be between low and high. It's got to be in there somewhere. And it's just going to serve as sort of an amassing or congregation point for the numbers. So here's an example where we create 10,000 random numbers, pop them into a list called nums, and we're going to use this triangular random number generator that's going to inject that bias. And we're saying a bias of 20 in a given range of 10 to 100. So everything will be really stacked in the lower numbers. Now, as a course of demonstration, here's just a quick plot of it. We can just import matplot library, and that gives us cool access to some very easy graphical representations of our data, including histograms. So here is, once you import that, creating a histogram for any list is easy. You just give it the list name and then the number of bins. And again, this is for continuous data. And if we show this here, well, we can see that normally, if we were to select random numbers between 10 and 100, and we had 10,000 of them, we would want to see a uniform distribution. But here we see that there's a lot more skewing instead around that bias value of 20. And our selections were significantly higher there and as we spread out from there. All right, and then you'll have another little plotting exercise to do here. And then there's just a whole bunch. I just list these here. We're not going to demo those, but there are a staggering number of random number generators that will use a variety of distribution methods, including Gaussian, logarithmic normal, and then Pareto. You know, those are some very, very specialized distributions there. All right, hope this helps, and make sure to tune into the next video, just where we talk through the math package.